Last week, we started talking about how to deal with water pumps in WaterGEMS software, or how to size a water pump by using a WaterGEMS software. Today, we're going to proceed with the same topic, and this is going to be like a follow-up tutorial to what we had on the previous week. So if you're new here, my name is Engineer Lodrick, and this is Hydroinformatics Academy. Without further ado, let's get started. Okay, so this is our network, and we want to size this pump by using WaterGEMS software. And we want to supply 4 liters per second from this source here all the way to our destination point. But this time our destination point is not a storage tank, but rather it's like a pond. Okay, it's like a pond, and we want to pump 4 liters per second from this source all the way to our destination, which is a pond. Not just that, we have some other data, like the elevation at this point here is 97 meters, and also the elevation at the minimum water level, which is this one. Elevation at the minimum water level is 98 meters. And not just that, elevation at the ground level, which is this point here, is 100 meters. Also, we have elevation data at this point here, and also elevation at this point, and also this one here. So the elevation at our destination point, or at our pond, is 150 meters. Okay, so as I said, we are pumping water from this point to this point, 4 liters per second from this point to this point. So the length values here, from this point here all the way to this point, the length is 300, and also from this junction here to this junction is 300 meters, and also from this point here all the way to this point is again 300 meters. So we want to size this pump for this network, of course, by using our WaterGEMS software. Let's see how can we achieve that. Let me minimize this. And this is my WaterGEMS software. For now, I am using WaterGEMS Connect Edition. Of course, feel free to use any WaterGEMS version that you have. Okay, so by starting, the first thing that I need to do is to open a new project. Okay, so let me go here to files and open and click new. Let me click yes. So this is my WaterGEMS, of course, with a new project. Now from here, what I need to do before I do anything, let me make sure that I have the required setting for my project. So to achieve that, let me go here and select options, and then let me select the base. So let me select this point here, and also let me select properties. Here we have several options, but the key properties that I need to change is friction method. Of course, if you want to use any of these friction methods here, feel free to use them. But for simplicity, I'm going to use the Hazen-Williams friction method. Okay, and the next parameter that I need to change, of course, it is a calculation type. Of course, for now I'm dealing with only hydraulic, but feel free to change other parameters as well. Now from here, I don't think if I have. Okay, so because for now I'm not dealing with extended period simulation, then let me stick with a steady state analysis. Okay, so from that I need also to select engine compatibility. Of course, you can use the EPANET engine, but for now, let me stick with the default engine, which is our WaterGEMS 2.0. And the next parameter that I can change, I don't think if I have anything to change from here. So the next thing that I need to change is the units. Okay, so we have two options to deal with the units. So the first one here, let me go here to tools and select this one. Of course, we have this option here, but for simplicity, I'm not going to use this option, and I'll show you how to deal with the units as we move along. So let me close this for now. Now we are done with settings. Let me go and make sure that I have this network in my WaterGEMS software. So I need to draw this network in WaterGEMS software, and this is very, very important step as far as hydraulic modeling is concerned. So let me start with this. As you can see, we have our source, which is this one, and also we have our destination point, which is this. Also we have the elevation data. Of course, the length data is here, and I don't think if I have anything more. So let me go back to my WaterGEMS software. Now from here, let me go to home and select the layout. Okay, now because this is our source, and to model source in WaterGEMS, we need to use a reservoir. So from here, to achieve that, what I need to do is to go back to a layout, and because for now as you can see, the junction option is active. I don't want to use the junction for now. Let me right click and select the reservoir. So this is the reservoir. So if I click this area, I need to introduce another parameter, which is a pump. Okay, this is our pump. I need to introduce it. Okay, so let me go back here and right click, then select pump. Okay, so this is our pump. Then I need to introduce another junction here. Okay, so let me select junction. This is our junction. And also if I go back here, you can see we have, so this is our first point. We also have some few junctions here. So the first one is this one and also this one. Okay, so let me minimize this and let me start with so this one is the first, and let me introduce the second one here. If I go back here, okay, so we have this 300, which is 300 meters, and also this one here is 300 meters, and also we have this other one, so it is 1 2 3. So I need to have 1 2 and also this one. Of course, the last point here is the destination. So as I said earlier, for our case we don't have a storage tank, but rather we are pumping water from a source to like a pond. Okay, so we need to find a way to model a pond in WaterGEMS, and to achieve that, let me use a reservoir. Okay, so we have the first reservoir, which was our source, and also the second reservoir, which is our destination point, a pond. Okay, so let me show you how to deal with that. Okay, so at this point, what I need to do is to introduce a reservoir. So let me find a reservoir here. So this is our reservoir. Okay, so, and because I don't have any other point, let me right click, then click done, and also click, of course, click done again. Okay, so now that our network is done, the next step that we need to do is to make sure that we provide the required element properties for our model. The properties like pipe length, the junctions elevation data, and also the reservoir elevation data, and also for the elevation data for our pump. And to achieve that, we have several approaches that we can use, but the simplest one is by using flex table. So let me show you how we do it. Okay, so let me start with the junctions. Okay, so let me start with the junctions, then I'll move to reservoirs. So with junction, we have the option, of course, by putting the values one by one, of course, manually. But the simplest way, as I said, is by using flex tables. So with flex table, what we need to do is to go to this area here. Let me select this one, and also select the flex table for junctions. Okay, so this is our junctions. This is our junction, if I'm not mistaken. Now from here, I need to start with junction number 1, which is this one. So the junction number 1 from our sketch, elevation is 100. Okay, so the elevation here is 100. Let me go back here and select my flex table. So the elevation here is 100, of course, meters, 100 meters. And also for junction number 2, if I go back here, you can see so junction number 2, the elevation value is this one, 120, and also the last one is 135. So if I go back here, let me select this, so 120 and 135. So that is how we can use flex table to insert elevation data in our junctions. So let me move to our reservoirs. Okay, our reservoirs, of course, by using the flex table again. So let me select this and select reservoirs. Let me select reservoirs. Okay, this one. Now from here, the reservoir number 1, which is this one, is our source. Okay, so if I go back here, where is my source? So this is my source. Now, because this is our minimum water level, our pump is going to pump water from this point, not this point. So from here, let me select the elevation data for our reservoir, which is R1, as this one, which is 98. Okay, so let me put here 98. This is the point where our pump is going to push water. Now from here, reservoir number 2, which is this one, so the value of elevation here is 150. So let me go back here and select 150. Okay, and let me close. So if I double click one of them, you can see we have the elevation here is as 28 meters, and also here we have elevation data as 150. Okay, so the next step is to make sure that I provide elevation data for our pump. Okay, so let me double click this. This is our pump. Again, if I take you back here, you can see this is our pump, but as I said, our pump will start to push water from this point here and not this point. So from here, let me select 98. Of course, this is elevation at our pump. Let me select this one, elevation here, 98, and let me close this. And I think we are, as far as elevation goes, I think now we are done, because even for junctions here we have the elevation data. Now the next thing that we need to do is to make sure that at least we provide the length data for our pipes. Okay, so we need to provide lengths for our pipes, and to achieve that we are going to use the same approach, that is flex tables. Let me show you how we do it. Okay, so if I open my sketch here, you can see the length here is 300, 300, and also 300. Okay, so the length from this point here all the way to this point is 300, and also this point here 300, and again the last point here is 300 as well. So if I minimize this and let me go here, so from our pump, so this P2, the length here is 300. Of course, as I said, let me use the flex table. So for pipes, the length here is 300. Let me find the length, but as you can see, for now I'm not able to edit. So what I need to do is to make sure that I select as user defined length. So let me tick, at least to get that option of inserting our length values manually. So from here, this is pipe P2, which is this one, and the length for pipe P2, which is this. So the length for pipe P2 is 300. Let me select here 300, and also the length for pipe P3, 4, and 5. Of course, the length is the same. So let me put here 300, 300, and also this one here 300. So that is what we have. Okay, so let me close this flex table window and see what we have. Okay, so the length here is 300. Where is 300? Where is the length? Okay, so the length here is 300. Of course, this is what we wanted. And also this one here, what is the length? And also the length here is 300 as well. But the question here is, we also have another pipe here, which is pipe P1. Okay, so let me do this, move this one. So we have another pipe, which is pipe P1. And if I take you back here, you can see like this pipe P1 is not here in our network. So if it is not in our network, how can we deal with that? Okay, so pipe P1 does not exist in our network, and it is there because that is the only way WaterGEMS could be able to link our source, which is a reservoir, with our pump. So as designers, what we need to do is to make sure that we model this pipe P1 in such a way that it has a very small or very minimal head losses, and hence it has zero influence in our network. And to achieve that, what we need to do is to provide a very small length and a very large diameter values. Let me show you how we can do that. So if I double click this, if I double click P1, you can see, let me go straight to physical. So what we need to do is to change the length. So let's start with the length. Okay, let me specify here the value as true, and also I need to provide a very minimum length for our pipe P1, and for that let me provide like 0.01, and also the diameter. Okay, so let me go back to the diameter. Let me provide a very huge size for our diameter. So let me assume like we have 150, okay, as diameter value for our pipe P1. Okay, so remember, diameter here we put the largest possible value, and also for the length we put a very minimum values. Okay, so the idea here is to make sure that pipe P1 has zero influence in our network as far as head losses values goes. Okay, so let me close this. Now that we have our values, what we need to do next is to validate our model and see if we have anything wrong with our network. So from that, let me click validate. It seems as though we have some issues here, and that is nothing but we need to provide the pump curve for our network, for our pump. Okay, as you can see here, pump curve is required. So let me go back to our pump. I need to provide the pump curve for our pump. So if I go here and select pump definition, so if I double click pump and I select pump definition, you can see we have this value here. So if I select this drop down menu and select edit pump definition, then this is what we have. So what we need to do here is to make sure that we provide the data for the required pump curve. So if I select new, let me give it a name like pump 1. Okay, so if you can see here, we have several options. Let me select this one here. Okay, let me select this, and because we want to pump 4 liters per second from our source, let me put this as the value, 4 liters per second, and the next value here is the head, of course the pumping head. Okay, so far what we have seen is that for our pump to be completed, we need 2 values. So the first one is Q, which is discharge, which we have already, and the other one is pumping head. So the question is, how can we get the pump head? Well, we have several approaches, but in this tutorial, what we are going to use is the iterative method, and we are going to run several iterations, and we are going to select the pump head in which our pump is going to deliver the required discharge at our destination point, which is 4 liters per second. Let me show you how to do that. Okay, so the first value that we are going to use for our first iteration is the static pumping head. So if I take you back here, you can see we have several values here. So if I take this one and minus this, what I'm going to get is 52. Okay, so 150 minus 88 meters, that is 52. So that is going to be our static head. Okay, this is going to be our static head, and that is going to be our first value for our first iteration. So if I take here 52 as our first value, 52, and I close this, so I need to go back here to pump definition and make sure that I select the pump curve. Okay, so as soon as I select this pump curve, you can see that WaterGEMS pulled this data from our pump curve to this area. Okay, so this is our head, of course, at the shut-off point, and also this is the head at the design point, which is 52, and also this is the flow, of course, at the design point, which is 4. So if I close this and I validate my model again, you can see for now I don't have any issue. So what I need to do is to run my model. Okay, so for now, let me take you back here. You can see for now our model ran 3 trials. Of course, the flow is 4 liters, which is not bad. Let me close this and see what can we achieve from here. So let me double click first on this one, pipe P1. Of course, any pipe, you can just click any pipe, because what I need to achieve is to change the unit for the flow. Okay, so let me select this flow and change the units. Okay, so if I select the unit format, and I need to select here 2 decimal places, at least 2 decimal places, or at least 1. Okay, so you can see for now that is what we have. Let me go back here and select pipe and then add annotation. Okay, and what I need to do from here, let me select the results, then go to flow. Let me go to direct to flow, which is this one, and I need to click apply, but you can see for now is not that visible. So let me move it down by -2, of course in y direction -2, and let me select apply. Okay, so that is our first iteration, and as you can see, for the assumed pump head, which was 52, our pump is delivering not 4 liters per second, but 3.94 liters per second to our destination point. But what we're interested is not 3.9 or 3.2. What we're interested is to make sure that we have iteration where our pump is going to deliver 4 liters per second. So for the first iteration, the results are not very good. So what we need to do is to change a little bit and see if our pump is able to deliver required flow, which is 4 liters per second. Let me show you how we can achieve that. Okay, so that was the first iteration. So what I need to do next is to have the second iteration. Remember, the objective here is to make sure that our pump is delivering the required discharge, which is 4 liters per second to our destination. So second iteration, if I go back here and select my pump curve, you can see the value that we had was a static head value. Of course, this was for the first iteration, which was 52. But what I need to do next, let me increase a little bit this value to around 55, and let me close this, and also let me change the pipe diameters with, of course, by using a flex table. Let me go back here and select, at least let me take it back to 1110, and also this one. Of course, remember, you need to use the internal diameter. For now, I'm using the OD. Of course, this is the simplest way, but you need to use the internal diameter. That's very important. So let me close this. So from here, let me run my model. Of course, this is, and let me display the flow. You can see now the flow here is 4.04 liters per second, which is approximately to what I need. And let me check the velocity. You can see the velocity here again is 0.42 meters per second. Okay, but the issue here is, of course, the unity head losses. Feel free to go and play with it, but for now, I'm totally satisfied with these two values. Okay, so for now I can say that since at this head my pump is delivering 4.04 liters, this is exactly what I want. Of course, feel free to go and play with several values, at least to get more better values to what I have right here. So what I need to do next is to see what I have here as far as the report goes. Let me go back and select the pump and also select this value here. So you can see the required pump here, it has a discharge of 4 liters per second, and also the pumping head of 54.68 meters. Okay, so that is the required pump for my network. But as I said earlier, this was a follow-up tutorial to what we had in the previous weeks. So if you are coming from that tutorial, make sure that you watch the first tutorial on my screen here. And also, if this is your first time you are watching tutorials about pumps in my channel, just go and watch the previous tutorial. Of course, will be the second tutorial in the screen. Links to both of them will be in the description below and also in the first comment below. So just go there and watch them. With that being said, thank you, and I'll catch you in the next tutorial.